All right, everybody, can you hear me? Cool. Just a couple of housekeeping notes before I start. Don't worry about writing stuff down or taking pictures of the slides. I'm going to post the deck on my GitHub when I'm done. Also, there is a demo component later on. It's pre-recorded, but if you're sitting toward the back, it might be kind of hard for you to see because I'm going to be stepping through the Security Onion interface a little bit. So if you want to take the opportunity either now or later on to move up so you've got a better view, that might be a good idea. As Kat said, my name is Matt Gracie. The name of this talk is Building a Sawmill, Processing Logs with Security Onion. I find that when I'm writing talks, the best thing to do is start with a terrible pun and work backwards from there. So it seems to work out for me most of the time. Thanks very much for having me. Now that I've spoken at BSides Cleveland, BSides Buffalo, and BSides Pittsburgh, I feel like I've punched all the squares on my BSides Rust Belt card. So who am I and what am I talking about? Well, my day job, I work on the professional services team at Security Onion Solutions. How many people have used or encountered Security Onion before? Okay, excellent. We'll get into some of the details about the platform in a minute. What I want to mention at this point is I work for Security Onion Solutions, which is a commercial company that provides support for Security Onion, the software platform. This is not a vendor pitch. I'm not going to show you anything that costs money. If you want to play around with the software, you can go to our GitHub and download it. We don't even want your email address, okay? So please don't feel like I'm trying to sell you something. I'm really not. But this is what I do. I do professional services for Security Onion. I also record a lot of our online training content, a lot of our YouTube tutorial content, write documentation, that sort of thing. So if you just can't get enough of the sultry sound of my voice, it's available on our YouTube channel. I'm also an adjunct professor at Canisius University in Buffalo. We have a graduate program in cybersecurity, so I've been teaching there for a few years. I teach the what we call the cybersecurity operations course, which is the blue teaming course, and also the red teaming course. And I organize a bunch of community stuff. Like Kat said, I'm the founder and lead organizer for the B-Sides in Buffalo. I also organize a monthly meetup called InfoSec 716. Some of our events are virtual and online. Some of them are in person. So if that's something you'd be interested in, we're on Meetup. You can find the event schedule there. So what am I talking about today? You may recognize this architecture. This is something called a panopticon, where you can see everything that's happening in a building from one place. In case you're curious about what the one place is, it is that place. What we want to do in our network is build a virtual panopticon. We want to be able to see what is happening in each location on our network, to be able to zoom in and gather telemetry and log information and see everything that's happening from a single vantage point, and ideally be able to pivot between those different data sets and those different log files so that we can look for patterns and make correlations, right? If you're in an enterprise environment, or hell, even if you're on your home network, you've got dozens of different things available that are all generating log files. So what we want to talk about today is how we can take those log files, put them all in one place, and use them for investigation. Just to talk about some basic log types that you'll see in an enterprise, right? You've probably got Windows boxes. Most people have them. Those Windows boxes are going to generate their own individual operating system logs. You've got the standard event logs, application, system, security. You may have things like PowerShell logging enabled. You may have something like Sysmon deployed. Those are all generating stuff and sending it to the event logs on that Windows box. If you have an Active Directory environment, domain services, things like IIS, those logs are all being generated as well. Some of them are easier to gather up and put in one place than others, but they all provide very useful context for the events that are happening in your enterprise. On the Linux side, you're going to have a similar breadth of log data being generated. However, it's sometimes more difficult to deal with. The reason for that is, while on the Windows side, you've got sort of a standardized framework around event channels and event IDs and things going into one bin, with occasional exceptions like DNS or IIS logs. Linux is a little more freewheeling. Sysmon for Linux is pretty much dead. Audit D is a nightmare. So there's a bunch of different frameworks and different methodologies that you can use in the Linux world, but in any case, you need to get those logs, you need to put them in one place. Same thing with Mac OS. There's some stuff specific to that operating system or specific to the underlying subsystems that's a little bit trickier than Windows, but it's still stuff that we want to pull in, that we want to look at. Network devices, things like firewalls, VPN concentrators, load balancers. These are all generating logs. A lot of them will generate logs in stuff like CEF format. Some of them will have their own custom formats. Some of them will send via syslog. Some of them will require you to pull it via an API, but they provide a lot of really interesting context around what's happening on your network. A lot of times the network devices will be in a separate subnet or a separate VLAN or a separate section of your network from the endpoints. So being able to pull the logs in from those will give you visibility into spots where you may not have it otherwise. Cloud services, everything is in the cloud. Every company wants to be cloud first, by which I mean every company wants to take their poorly maintained VMware instances and forklift them up into AWS for $1 million a year. But one of the things that you have to account for when you're doing this cloud stuff is that the logging infrastructure and the telemetry infrastructure is often very, very different. You're not going to have the same ability to watch things like network traffic via span ports, right? Unless you're in AWS, you're not even going to have native mirroring support. What you are going to have is things like CloudTrail, writing logs into S3 buckets, and then you can retrieve those and parse them, right? So the telemetry is still there, but again, it's coming in a different form. It's a little bit more complicated to pull down. You need to normalize it, and that's what we're going to talk about. And finally, endpoint agents. I put this on here because a lot of people don't realize that the data that's being collected by your endpoint agent, if it's something like CrowdStrike or Sentinel-1, you can often import that or use that outside of the vendor's infrastructure, right? People think that if they've deployed CrowdStrike, Falcon, Rainbow Bright, or whatever their current product is, that you can only see it through that web console. But there are integrations available where you can pull it into something else and correlate it with other data sources, right? And that's something we're going to talk about. When it comes to gathering these logs and putting them in one place, there's three sort of primary techniques that we can use. The simplest is if you have an endpoint, that is if you have a Windows box, a Linux box, a Mac OS box, you can just install a copy of the Elastic Agent on there. And again, I'm talking about in this security onion architecture. By default, we ship the Elastic Agent pre-configured for your security onion deployment. It generates an installer when you do your initial deploy. That installer has policies in it for doing things like gathering Windows logs, gathering telemetry information, information about network activity, information about DNS activity, stuff that's happening on the particular endpoint. You can also configure it to scoop up other logs. So for example, if you have a Windows web server and it's running IIS, and that IIS stuff is all being written to flat text files, you can put that file path into your Elastic Agent configuration. It will pull that stuff up and send it along with all the other log data, right? So you've got it all in one place. For network devices, generally speaking, you're going to be looking at doing syslog ingestion. Excuse me. So if you've got a Palo Alto or a Fortinet, you should patch that. Or if you've got a VPN concentrator, Meraki, something like that. Generally, those are going to allow you to package up those logs and send them via syslog to a receiver. On the security onion side, that receiver is going to be an Elastic Agent running on one of your nodes in your security onion grid, and it's going to be hooked to an integration pipeline. Elastic has a bunch of these ingestion pipelines that are pre-built. So you basically say, hey, if anything comes in on port 9001, that's Palo Alto traffic, and then it will hand it off to the proper pipeline to ingest everything and normalize it for you. Everything is kind of pre-built. It's pretty cool. Finally, if you're trying to pull logs in from your cloud services, obviously you're not going to do that via syslog streaming down from the cloud. You're probably going to do that via API retrieval. So you'll talk to your cloud team, get a service account set up with an API key, and then you'll be able to pull that periodically and pull log entries down. If you're using something like CloudTrail for your VPC logs, for example, it writes those VPC logs as small JSON files and sticks them in an S3 bucket. You basically just connect to a simple queue service queue and connect to that S3 bucket and pull the logs down one at a time. They'll get normalized and put in with the other stuff. One thing I will caution you about, the way the Elastic Agent configuration works is an Elastic Agent policy is applied to the agent, and that policy tells it what sort of logs to handle. Do not accidentally tell 15 different things in your environment to all pull logs from the same S3 bucket. It's going to get real messy. Just pick one, just one, and have it do it. Now, the other piece of this, what is Security Onion? This is from our website. Security Onion is a free and open platform built for defenders by defenders, which is true. I was just telling you right before I started talking, you know, I always say that our secret sauce is everyone at Security Onion came from that blue team life. We are all just building the tools that we wanted when we were doing network defense, which is why it's all so awesome. People think of it primarily as a network visibility tool, which is one thing that it can do, but it also has a lot of log management functionality, which is the piece that I'm talking about today. So the main components of Security Onion. There are some other specialty nodes, things like honeypots that you can stand up, but the three main components that people think about are management, search, and sensor. The management is the section of the functionality that does things like the web interface and the configuration, right? So if you're in your browser and you're doing engineering work, you're integrating things, you're configuring things in your grid, that's management. Search is the Elasticsearch backend. That's where the data that ingests is stored. And then sensor is the packet capture, the IDS, the metadata generation functionality. So either stenographer or suricata for packet capture, suricata for IDS, and then either Zeek or suricata for network metadata generation. When these are all working together, you put them all on one box. It's what we call a standalone deployment, right? Because you've got one server that's running all of this functionality at the same time. And this is the most basic use case. If you're running a small Security Onion instance in a lab or at home, odds are that you're either doing it as an import node, meaning you're just importing PCAP into it, but if you're doing it with live network traffic, you're probably doing it as a standalone, right? Everything's on one box. All of these components can be broken apart and run on separate boxes. It's a very flexible platform, so if you've got a geographically distributed enterprise, or if you need to put sensors in different places, or you know, if you want to do hot, cold life cycle on your data, you can have multiple search nodes. There's a million different ways to set it up. This is the most basic. The one we're talking about today is what we call a manager search. That is, we've got a node that's running the management components and the search components. And this is what we're going to see in the demo. So it's running the web interface, the configuration. It's also running Elasticsearch so that it can retain the data that we've collected. It's not running any sensor components, okay? And I just want to mention that again before the demo. It's not watching network traffic at all. It's just ingesting logs from the outside. So what does the ingestion flow look like when we're putting logs into this manager search? Well, we start with the log source, whatever it might be, an endpoint or a network device or a cloud service, you know, whatever it is that's generating the logs that we want to see. That log source passes the data in some way, and we'll walk through the Windows example in a minute, to the Elastic Agent. The Elastic Agent is what we use as the log shipper in the environment. So that's what initially accepts the logs. It sends them to a Logstash receiver, which in this environment is running on the manager search. And then that Logstash receiver dumps them into a queue, and they end up getting ingested by Elasticsearch on the back end. So for example, if we're talking about a Windows endpoint, again, Windows is going to be generating the basic event logs. It's going to be generating system logs, security logs, application logs. It's going to be generating PowerShell logs. It may be generating sysmon logs if you've deployed sysmon in your environment. It could be generating any application-specific event logs. It's going to generate all those logs. It's going to put them into the event repositories on the endpoint itself. The Elastic agent, which we've installed on the Windows endpoint, will then scoop those EVTX events out, right? So it's reading those events as they're written to the files, marshaling them all together, getting them ready to send to Logstash. In addition to those basic events that it's generating, the Elastic agent is also generating its own telemetry information. And this is something that we'll see in the demo. So how many people have deployed sysmon before? All right. So how awesome would it be if you could deploy sysmon but not have to deploy a configuration file for it and not have to keep that up to date and not have to do updates every so often, right? Right. What the Elastic agent does is it gives us that sysmon style telemetry without requiring sysmon. So things like DNS queries being made by processes, network connections being opened, files being written, processes being launched. That telemetry is all picked up by Elastic Defend, which is part of the Elastic agent, and marshaled and sent along with all the other log data, right? So we're getting a lot of good in-depth visibility into that endpoint straight from the Elastic agent. As I mentioned, if you're running another EDR agent in your environment, if you're running something like CrowdStrike, we can pull a lot of that data out of there as well, right? So you don't have to scoop it all up twice. You can just put it in one place. After the Elastic agent takes the event data that was generated by Windows and also the telemetry data that it generated itself, it sends it to the Logstash receiver. In this demo environment we're talking about, the Logstash receiver is going to be running on that manager search node, right? That's basically the service that's receiving the communication from all of these Elastic agents out in the field. If you're in an enterprise deployment, we do have a specialty node type that's just called a receiver node for doing availability and load balancing. You can stand up a bunch of those and it will just round robin between them. But again, this is a demo environment, it's pretty small. Once the Logstash receiver gets it, it's put into a queue, and that queue is then emptied by Elasticsearch. So the stuff goes into an Elasticsearch ingestion pipeline, is all broken apart, ingested, and put into Elasticsearch on the back end. Elasticsearch is the component that handles the parsing and ingestion. It's also what handles the lifecycle management. So if you have certain logs that you want to keep longer than others, if you have stuff that you want to move from hot storage to warm storage, anything like that, that's all done on the Elasticsearch side. Now, there's two features that I want to mention that are very important for this. First is the Elastic Common Schema. Elastic Common Schema is an open format, format's probably not the right word, an open standard for what to name the different fields and what to retain them as and how to format the data, right? If you're pulling in log data from a bunch of places, and I know anyone who has tried to build a logging infrastructure has run into this, you're quickly going to discover that your IDS calls it source.ip, your firewall calls it src.ip, Zeek calls it host.originator, right? It's the same piece of data in all of these different log types, but it's coming in with different names. So if you're just doing straight ingestion and straight parsing of it, say it's all coming in as JSON and you just save those tags, it's going to be useless. You're not going to be able to pivot between these different data types because they're not going to be calling the data the same thing. If I want to see everything from a source IP, I want to just say source IP equals such and such. I don't want to remember all the different field names. So the Elastic Common Schema is the standard that we use to normalize all this data coming in. When you ingest something, the source IP is called source.ip. That's it. If it's called something else, we change it at ingestion. So everything gets normalized, right? That way all of the data is categorized and set up the same way to make it easy to pivot between things. Now the next piece is community ID. This blew my mind when I found out about it, right? So community ID is another open standard. It's by Corelight, which is the commercial company behind Zeek, formerly Bro, if you're old and gray like me and deployed this stuff a long time ago. What community ID is a hash of the source IP, the source port, the destination IP, the destination port, and whether the flow was TCP or UDP, right? That's what the standard is. It's those 5 pieces of information hashed together in a particular order. Why is that important? Because any piece of network log data that we ingest can have a community ID generated for it. And if we're ingesting multiple pieces of network data from disparate sources, and they've all been normalized so that source IP and source port and destination IP and destination port mean the same thing, that means that even if there's no other relationship between those monitoring platforms or those products or those datas, we're going to be able to pivot between those data sets very easily and correlate them together, right? And we'll see this in the demo as well. But it means you can take a network flow record from your firewall and endpoint information and something from your antivirus and maybe something from Zeek and see all of those records that are related to that flow all at the same time. It makes it super, super easy to pivot between the different data types. All right, so we've deployed our Elastic agents, we've done our configuration, we've built up all our pipelines, we've figured out what we need. What do the tools look like that we actually end up using in Security Onion? And I'm just going to step through these kind of quick because this is also the stuff that we're going to go over in the demo. You'll get to see it live and in 3D. So if you have something on your network that is generating alerts, you can configure those to show up in your alerts queue in Security Onion. So if you have a cloud service that generates alerts, right? Something like Sentinel, you can pass those down to us. They'll go into the alerts queue, and then your analysts will have that queue to work from, right? They'll be treated just the same as any alert that was generated internally in the platform. We have a dashboards tool that has a collection of pre-built dashboards for different data types in it. If you're running with our sensor components, you get data dashboards for things like Modbus and other ICS protocols, as well as a bunch of IT stuff, you know, DNS, HTTP, et cetera. But even if you're not using our sensor components, there's still dashboards for endpoint activity, sysmon, GeoIP, firewall logs, all that sort of stuff. These are all pre-built. They're also all fully interactive, as we'll see momentarily. This is our Hunt interface, which was really designed as a flexible, high-speed query interface for threat hunting through all this data. The idea being that you can sort of slice and dice and stack the data very quickly and easily, and we'll see that in the demo. And then finally, this is something we just released in version 2.4.70. This is our new detections interface. Is anyone familiar with Sigma, the detection language? Does that sound familiar? Okay, a couple hands. So just to give you the quick 30,000 foot view, somebody realized that we were wasting a lot of time as an industry rewriting detections for multiple platforms, right? Some new threat would come out and someone would be like, all right, well, I'll write a detection for QRadar, God help me. And somebody else would be like, well, I'll write a detection for Elastic. And somebody else would be like, well, I'll write it for Splunk, right? Super friends. The problem is, A, that's a massive duplication of work because we're all doing the same thing. 2, we have no assurance that those detections are really all doing the same thing if they're being written by different people in different query languages, right? So somebody came up with the concept of Sigma, which is sort of like a meta language for writing detections. Basically, you write the detection in Sigma, and then you compile it into the appropriate query language for the database or SIM or security tooling that you're using. So this is a Sigma rule for detecting somebody trying to clear the Windows console history. And if you're importing PowerShell logs into your Security Onion instance, you can turn this rule on, And it will say, okay, if the script block text contains clear history, or if it contains remove item or RM, and it contains these paths, then it's probably something suspicious and will raise an alarm, right? The idea is that we're writing OS and SIM agnostic queries looking for particular log entries. So our detections interface comes preloaded with, I don't know, a couple thousand rules. I just picked this one sort of at random. But you can turn these on, and when you're ingesting all these logs into Security Onion, it will run these queries against it every 3 minutes, I think. And if a match is found, it will raise an alert for you, right? So even though you're not running Suricata or Zeek or whatever, you can still do alerting against these logs that you're bringing in. Okay, so that's enough of that. Time for a demo. This is pre-recorded, so I won't have that nightmare where all of my VMs crash at the same time. Once was enough. The demo environment that I'm using is very, very simple. We've got a Windows 10 VM, a pfSense firewall. Traffic from the Windows VM is going, I'm still wearing those ears. Traffic from the Windows firewall is going out through from the Windows box is going out through the pfSense firewall. I am not monitoring this traffic at all. I just want to mention that again. None of the sensor components are enabled. My visibility is coming from logs that are being sent from the Windows 10 box via a Elastic agent installed on that box, and logs that are coming from the pfSense firewall via syslog over to the Elastic agent running on my Security Onion manager search node. So I'm seeing everything. It's all hearsay. I'm not seeing any of this directly. It's all log files. The pfSense box also has Suricata installed on it, which will become important shortly. Everyone's familiar with pfSense, I assume, right? Okay, open source firewall. If this was an enterprise environment, you would set it up the same way, but you would set it up with a Palo Alto or a Fortinet, patch it. But for now, it's pfSense. So I'm going to put the mic down for a sec and bump over to the demo. Okay, we are playing. So we're logged into the console. This is the overview screen. All of the tools that make up Security Onion are over on the left-hand side there. I'm helpfully pointing them out. So the first thing we're going to look at, I believe, is dashboards. Now, all of these tools have pretty similar interfaces. There's a query box in the upper left corner. There's an options menu up at the top, and then over at the right, there is a time selector. So in this case, we're looking at the last 24 days. Again, very small test environment. Just want to make sure I had some interesting stuff to look at. This is the overview dashboards. This is just sort of an overview of all the data that's being stored in this manager search right now. So you can see what hosts are in there, source IPs, destination IPs, different categories. These tables are all interactive. So if I want to add something to my query, like I just clicked pfSense include, meaning add that to my query. So now I'm only seeing pfSense module data here. All of those visualizations and tables update right away. I can add stuff to my query as well. So if I want to see pfSense and I only want to see destination port 80, that's what I just did. And if I scroll up to the top, come on, you can do it. There we go. You'll see pfSense and port 80 are both on there. And then I can just click to remove those and go back to the standard dashboard. So the idea is that all of this data is in here, and these visualizations are very easy to manipulate and carve around if I need to. If I pick source IP, and I'm just going to pause this for a sec to point this out, you'll notice I selected a source IP, and then over here under event module, I've got endpoint and pfSense. This is part of that Elastic Common Schema thing I was talking about. I'm ingesting data from two different sources, which may call it different things, but it's all being normalized to the same name on the back end. So when I search for it, all of the stuff gets clustered together. And now, because this is network information that's coming from an endpoint, it's got a bunch of additional data in it. Right? This is all process information. So I'm not just seeing that network traffic happened. That's what I'm seeing from the firewall logs. In this case, I'm actually seeing the process information behind what happened. What process launched it, who signed the process, where was it launched from, what was the user account, etc. So how many of you have had a situation where you got an alert from an IDS, right? Snort, Suricata, something like that, and you went and you talked to the user and you said, hey, user, that's what you call your users, what were you doing at 10:10 that your computer was contacting Russia? And they're like, "Mah." And that's the end of it, because you really can't tell. If you've got this logging in place, you're going to be able to see exactly what process they launched that caused the weird traffic that's showing up in an alert. So now we're just going to step through a couple of the dashboards. This is the Elastic Agent overview. You can see over on the left there, we've got logs for registry events, file events, network events, process events, pretty much anything that happens on a Windows box. If I want to go in and say, you know what, I've got this ruby.exe process name. I want to see every box in my environment that's running it and which user is doing it. I can get all that information. Now, for processes, I've also got some really interesting hierarchy data here. This is the process entity ID, which is a GUID that's assigned by Windows and then picked up as part of the telemetry. This does not mean the executable name. This does not mean the executable on the machine. This means this particular process. So this time that this executable was executed on this machine gets this GUID. If I pivot on that, you'll see I not only get the process information, I also get things like the command line, any DNS queries that it made. I get file information about any files that it touched. I get library information about any DLLs that it loaded. All of this stuff comes in. And again, I don't even have Sysmon loaded on this endpoint. This is all just straight default out of the box Elastic Defend. I did almost no customization of any kind. You can tell it's still named like Windows 10 Edge Test or whatever it is. This is that VM you get from Microsoft for testing IE. All right, this is my file events. I can get file creations, file deletions. If I go in here, say I see a weird file creation, I can do the same sort of pivot over to that process entity GUID, and it'll show me everything associated with the process that wrote a strange file. So if you see something while you're doing long tail analysis that looks suspicious, you can pivot in and see everything that that particular process did. You can also walk up the chain to see how that file was written to the disk in the first place. Then this is a process one. All right, again, doing the same thing. It's running as DWM1. Who spent time chasing their tail trying to figure out what that was? Oh, come on, I'm the only dummy, really? Processes come with the hash, so you can actually pivot straight from a process log into VirusTotal to see what it is. Also, that menu is completely customizable, so if you have some other threat intel source or something else that you want to do lookups in, you can modify the contents of that menu really easily. Getting away from the endpoint stuff, we can do some destination country analysis. This is all coming off of those firewall logs. As they're ingested through pfSense, they get enriched with geo-IP data, so we can see where everybody's stuff is going, from who to where. Now we get some good firewall data here. So this is all stuff coming off of pfSense. pfSense is natively supported for ingestion, as is OpenSense and a bunch of commercial firewall platforms. So if you're using Palo or Fortinet or Cisco or whatever, those all show up as well. You can go in and just look at your blocks and see what's getting blocked. So we've got a bunch of good built-in visualizations and dashboards here. If we want to do sort of more nitty-gritty analysis, that's kind of what the Hunt interface is for. If you've used, just going to pause this for a sec. How many people have used Kibana for this kind of thing, right? And Kibana is the tool that comes with Elastic. It's really kind of their default web interface for this stuff. How many people have been frustrated at how slow it is to use Kibana to do this stuff? Yes, and that is why we wrote Hunt. It's a lot quicker. Kibana has a lot of really, really good uses for stuff like reporting, but if you're actively doing a threat hunt in data, this is much quicker because it's really kind of purpose built for that. And it's going into that same Elasticsearch data. You know, it's two straws into the same shake. Kind of excited to see what I do next. Okay, so again, now we're looking at our endpoint file data. We can dig in here. We're doing a group by, so this is all of the different processes that have had file events in this environment, sorted by how many there were. I can turn that into a visualization if I want. I can turn off a slice of the pie if I want to see what the rest of it looks like. So I think it's kind of cool. Any of the field names that are in here after the data is ingested can be used as group bys or pivots. So I can build tables or I can build charts around any of the different data that gets pulled in through these log files. All right. All right, we're running up against it, so I'm going to skip ahead a little bit here. All right, when are you going to get to alerts? Oh. Okay, so if we're looking at network events, we can group that by the event action, and then we can zoom in on that for lookup requested. This is pretty neat. And now we can group by the process name and also group by the DNS query. So again, this is all the data that we're already pulling in, and with a couple of simple pivots, we can get a chart of every process in our environment that's making a DNS query and what exactly it's querying. So if you've got some threat intel or some particular ARN that you want to be able to dig in on, it's really easy to do that pivot. And again, I'm not watching the network traffic at all. This is all just coming from log data. And then one last cool piece. Oh, wait, no, the detections thing too. So, all right, that's the Sigma stuff. We're gonna skip that, much as I hate to do it, because I really want to show you this alert pivot. So I mentioned that. Oh, I went all the way around. Hang on. Blah, 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 blah. All right, so I mentioned that the pfSense firewall in the test environment is running Suricata. It's sending those Suricata logs into Security Onion. Security Onion is identifying them as alerts. So about halfway down there, I've got one that says ET info request for exe via PowerShell. That means I've got a PowerShell user agent in my environment that's trying to download an executable, right? So if we go down here, we'll drill down and that'll show us the individual alerts. All right, we'll go to the top one. Open that up. Now, as part of the Suricata alert, we're going to get network data decoded. So you can see that down at the bottom. Somebody ran get malice.exe, which seems super legitimate. And it's a user agent of Windows PowerShell. So that's why it got flagged. Suricata had a signature that said, if you see something with Windows PowerShell in it, raise an alert. Now, as I was saying, this is back to the user thing. If you ask your user, why did I get this alert, they're going to say, I have no idea, because it was something running in the background that they were unaware of. However, because we are ingesting this data, this Suricata data, and because the Suricata data is network data, it's got a community ID attached to it. The community ID allows us to tie together our log data from various network flows. So we can pivot on that community ID, and it will show us not only the network logs, not only the network data decoded, but it will also give us the other information from the endpoint logs about it. So we're going to see the stuff that Elastic Defend pulled off the endpoint, along with that Suricata alert that told us there was a problem in the first place. So we've got .4.100 going out to .10.69 on port 8000. We scroll down to the bottom here, we can see the process that opened the connection was PowerShell.exe. All right, you can do it. It seemed faster when I was recording it. And then if we go into actions here, we have a process ancestry action that we can run. And this will give us that full life cycle of the process. So we see here that winlogon.exe launched userinit.exe, launched explorer.exe, launched PowerShell.exe. We've got all the network information, we've got all the processes that were involved, we've got all the user information. We've got full visibility into all of the endpoint activities around this Suricata alert. And because we're using those community IDs as part of the log ingestion, we're able to pivot back and forth and do that correlation really easily. Okay? So I know we're just about at time. So in conclusion, people think of Security Onion as a network monitoring solution, and it is. It's really good for that. If you want to plug it into a span port or a tap infrastructure and get data around what's actually on the wire, it is fantastic. If you want to get a bunch of easy points in your next CTF, bring a Security Onion VM and throw all of the packet captures into it. It'll really work well. But in addition to that, even if you don't want to go to the trouble of setting up a tap or a span in your environment, if you just ingest the logs that you are already generating on all of these devices and all of these endpoints and all of these cloud services, you can put them in there, it'll be normalized, it'll be really easy to use for investigation and alerting, okay? That is all that I have. I'm going to put the slides up on my GitHub, as I said. That's my Twitter account. That's my email address if you want to reach out. I think there's some left. I put some Security Onion stickers and other swag on the table right over there, so help yourself if you want some. I don't think we have time for questions, maybe one or two, but I'm going to be here through the after party. So if you have questions about your janky Security Onion install on VirtualBox at home that you couldn't get to work right, I will be here. Just feel free to ask, okay? Thanks so much.